Good evening or good afternoon, depending on where you're joining us from today. We would like to welcome you to today's session of the Azure webinar series. Our topic today is Introducing Azure SQL, How to Choose the Right Database Service. Before we get started, I like to go over a little bit of housekeeping. We do have subject matter experts with us today who will be answering questions in real time, so please pop any questions you might have into the Q&A window and we will get to them as quickly as we can. Also, on the top right-hand corner of your console, you will find a resources area. Any links mentioned in this session will be easily accessible for you there. Right below the resources widget, you will find a survey. Please provide any feedback you have around today's session. Finally, this presentation is recorded and you will receive a copy of this presentation in your email within 48 hours. Our speaker today is Anna Hoffman, who is a data scientist from Microsoft. Anna, handing it over to you.
Thanks, Anita. Hi, everyone. I am happy to be here today and happy to be talking about Azure SQL, how to choose the right database service, and really what to use when. So if we kind of get right into it, we're going to talk about things like SQL Server on Azure Virtual Machine, SQL Managed Instance, SQL Database. I'm also going to cover a few interesting pieces around service tiers like hyperscale and options like serverless compute. And then we'll kind of compare and contrast, and I'll give you a ton of resources to go and learn more. So when I talk about Azure SQL, I like to start by talking about where it started. So in 2008 at the Microsoft Professional Developers Conference, or PDC, it's like our Microsoft Build now, Microsoft's chief software architect at the time, who was Ray Ozzie, that's who you see on the left, announced Azure, basically for the first time. And the reason I like this slide is because what you see is front and center is what was called at the time SQL Services. And I also found a blog post from around that time that was kind of the how to choose or what to use when for Azure SQL Database at the time. And, you don't have to read all this, but really the highlight is that you do not need to provision hardware for, install, or patch Azure SQL Database, and you don't need to architect a database installation for scalability, high availability, or disaster recovery, as these features are provided automatically. And the reason I like this explanation is because I think it remains valid today, though, of course, the capabilities around security, performance, and availability, as well as scale, have greatly been enhanced over the years. And we've really come a long way to include virtual machines, managed instances, and as you see in the past few years, several options for Azure SQL Database. And there's one more thing that we've done in 2020. I guess I should really add a new bullet to this timeline. And what we did is we launched this new branding effort of Azure SQL. And, Microsoft is famous or infamous for our name changing, but I think this one's going to stick at least for a little while. And really what we're doing with Azure SQL is kind of grouping all of the options for SQL running in Azure into one portfolio and kind of making it easier for you to see all of them together as well as to choose the one that makes the most sense for you. So if we just kind of start talking through these options, what I want you to remember or consider is that as we move from left to right, we're going to be moving more and more towards a type of cloud native solution. And what this means is while you might have less control, you in turn might get more capabilities that are provided by the cloud platform. Now, this first option is infrastructure as a service, or IaaS, and that's SQL Server on Azure Virtual Machines. And what this basically means is that we're going to manage the infrastructure, and you're going to manage the OS and the SQL Server. Now, if we abstract one layer higher from that and say, okay, I don't want to manage the virtual machine or the OS and be responsible for, updating and patching the OS or the SQL Server, we can abstract away the VM and kind of just give you a managed instance instance where you just manage the SQL Server. And then we have Azure SQL Database. So we abstract one level higher and say, okay, you don't need to manage the OS or the SQL Server, but you just want a database and you want to get building new apps in the cloud most commonly. And you also want to take advantage of some of the great innovations that today are only available in Azure SQL Database, like serverless and hyperscale. So now that we've kind of seen an overview of what Azure SQL is, we're going to dive a little bit deeper into the customer challenges that lead customers towards picking different options among here. And you'll commonly hear us refer to these options you see on the screen as the deployment options. So let's get right into it. The first is SQL Server on Azure Virtual Machine. Now, there are many challenges that lead customers to this solution. Their contract on their hardware could be expiring. Many customers, believe it or not, still have instances of SQL Server 2008 and 2008 R2, and they're kind of struggling to figure out how to either move forward or get to the next version or be secured by and supported by Microsoft. Other customers want to migrate to the cloud as fast as possible, and they don't want to have to change their applications. Or, they might use a third-party software, and this third-party is SQL Server and Azure Virtual Machine. There are a few other reasons that lead customers here. With SQL Server and Azure Virtual Machine, you really are just getting SQL Server. So you're going to get the expansive OS and SQL Server version support that you need. So you can kind of just move with the version that you're at on the OS that you're at and be supported by Microsoft. One of the key differentiators here is that if you are one of those customers, and you're not alone, running on SQL Server 2008 or R2, we're going to give you free extended security updates for the next few years, so that shift to upgrading or moving to a PaaS service or just upgrading in IaaS becomes less of a time-sensitive thing. Now, when I look at customers, because I like to kind of relate to these things via customers, I like a customer named Allscripts. And the reason I like Allscripts is because they were able to move about 600 VMs to Azure in, I think, a span of 2 weeks. And the reason they were able to do this is they leveraged a technology called Azure Site Recovery. And apart from that, they didn't really have to change much with their applications. This was really, a lift and shift type of migration. And another thing I like about Allscripts is once they got to IaaS or SQL Server on Azure Virtual Machine, they started to evaluate other things in the cloud, like Azure SQL Managed Instance, which they ultimately ended up moving some of those databases and servers to Managed Instance. So they're a really interesting example of kind of a common theme we see on customers of taking a phased approach to migrating to the cloud. Get there as easy as you can, and then start to, dip your toes in some of the other capabilities that Azure provides. Now, I wanted to spend just a little bit of time telling you a little bit more about SQL Server on Azure Virtual Machines. There are some different deployment options that you have. I kind of talked about this lift and shift idea with Azure Site Recovery. That's one. Another is the marketplace images. So this basically means you go into the Azure portal and you select the SQL Server version and OS that you want, and a few other configurations around storage and performance and even availability. And we're going to basically deploy it for you where SQL Server is pre-installed. Now, we understand many of our SQL Server professionals and data professionals over the years are not necessarily familiar with this idea of just deploying a pre-installed SQL Server. So we also have ways to support you if you, what we call self-install. So you deploy a virtual machine and then you go get the version of SQL Server that you need and you self-install SQL Server. And this capability is provided through Resource Provider, which I'll talk about in a moment. A few other things I wanted to call out, because you're running in Azure and you have the support of the various hardwares and technologies that we have in the cloud, you can get several things. You can get memory or storage optimized sizes to get the best performance that you need, but not more than the performance that you need. You can just pay for what it is that you need. There are some other strategies around data disk and where you put your data and log files. One thing to note is that TimpDB is going to be running on your local SSD. That's going to help keep you fast. And you can leverage things like accelerated networking or UltraDisk if you have very low latency needs. Now, one of the interesting things about security is that advanced data security, which was previously a platform as a service only thing, is now available in preview in SQL Server and Azure Virtual Machine. And this is pretty big because this gives you great security protection, including things like advanced threat protection, which can identify and alert you on things like SQL injection. For HADR, you can see there are a lot of things that we make available that you can set up. Now, we'll talk a little bit about IaaS versus PaaS in a moment, but here, what's important to remember is these are possibilities that you can enable. For example, if you wanted to create kind of a failover cluster instance, you can do that leveraging Azure Premium File Share. You can also set up always-on availability groups or leverage secondary replicas, and we even have support for doing HADR type of solutions on Red Hat Linux. So lots of options here for you to configure. Now, I wanted to call out one point about this idea of a self-installed SQL Server. So this is you deploy a virtual machine and then you install SQL Server. Before Resource Provider, which is basically a small agent you can install, which is going to connect your SQL Server that's running in your virtual machine to the Azure Management view, before this, you didn't have that capability to get some of the automated features that you get from SQL Server and Azure Virtual Machine. But now with Resource Provider, you can enable this even on your self-installed instance of SQL Server and start to take advantage of all of the different capabilities that I mentioned before and some of the other ones here, like understanding your compliance with regards to Azure Hybrid Benefit or your existing licenses, or taking advantage of some of the automated capabilities like auto backup and auto patching. So definitely make sure if you have any self-installed virtual machines today, or you're considering doing that in the future, that you enable Resource Provider. So that's IaaS. That's SQL Server on a virtual machine where you're still managing the OS, and at the end of the day, you're going to have to upgrade SQL Server when whatever the next version of SQL Server rolls around, or if you stay on 2008, eventually you're going to have to move to a newer version. So that's a big difference when we talk about IaaS versus PaaS, because platform as a service is versionless. That means that at a certain point in time, we've basically branched off from the SQL Server base engine, because it's the same engine across IaaS and PaaS and even our on-premises SQL Server. But with versionless, what happens is we're going to fork off, and as we create new things and new capabilities in Azure SQL, many times they'll land in this versionless PaaS service first, because we don't release every year or so. We can ship new builds as they become available. And this is huge, not only because it's going to help you get the latest and greatest technology, but you never are going to have to worry about upgrading again. So versionless is a big differentiator when we talk about IaaS versus PaaS. Another differentiator, I talked about, for example, how you can set up a failover cluster instance with Azure Premium File Share, or you can do always-on availability groups. Now with IaaS, you can set this up, yes, but there is some configuration required, and in some cases, it can get pretty complex. If you've ever set up an always-on availability group, I'm sure you can relate. Now with PaaS, however, we make these things a lot easier for you, and due to the SLA, or the service level agreement that we stand by, a lot of these things are done underneath the covers, which we're going to dive into today and see that, for example, general purpose just runs like a failover cluster instance without you having to do anything. So let's switch gears and talk a little bit more about the platform as a service type of capabilities. And the first one is Azure SQL Managed Instance. And this is something you've probably been hearing a lot about, hopefully. But basically, this is called an instance because it's the equivalent to a database engine instance of SQL Server. This basically means you're going to get close to the full surface area of what's available in SQL Server. This means that you're going to get things like Service Broker, SQL Server Agent, Database Mail, CLR, these instance scoped, that's kind of what we refer to them, instance scoped features you're going to be able to get in Azure SQL Managed Instance, where if you just get a database, you're not going to be able to get those sort of things. Now, there are some great benefits to Managed Instance. One is this native virtual network support, so you can deploy Managed Instance as an extension of your on-premises network. We also have things for Azure AD and AD Connect. Now, some other things related to actually getting to Azure SQL Managed Instance, leveraging Azure Database Migration Service, you can actually do a near zero downtime migration using a technology that's very similar to log shipping. And I like this last statement there under Azure differentiators. I've been doing a lot of work with Bob Ward, and this is one of the things that he says is that you're going to get the best of SQL Server with the benefits of having a managed service. So really powerful stuff that they're doing in Azure SQL Managed Instance. Now, a customer I like to talk about here is Komatsu, and the reason I like them is, as you can see, they were able to move with almost no code changes, and even more powerful, as you look at these numbers, right, they were able to pretty immediately see a 49% cost reduction. That's big. That's not like 5 or 10%. That's like almost 50% cost reduction, as well as 25%-ish performance gain. So you can really see some of the benefits that come with Azure SQL Managed Instance, and we'll talk more about those capabilities. Now, one thing you'll hear me kind of mention throughout the rest of the session is this idea of the power of PaaS. And what I mean by this is that, you get a lot just moving to Azure, hands down. But when you move to a platform as a service, a lot of these things that might have taken a long time can become very simple and very accessible. For example, if we talk about implementing a geo-distributed type of database or application, in the past, setting this up, even just getting the logistics to coordinate with the other data center that you might have in another region, maybe in another area of the globe, that can take a long time. It can be very complicated and can be very expensive. But with PaaS services, so Azure SQL Database and Azure SQL Managed Instance, we're making things like geo-replication and auto failover groups very easy. You can see here how I'm kind of comparing and contrasting geo-replication versus auto failover groups. But I think the main callouts is that with auto failover groups, like the name implies, you can automatically fail over in the case of some sort of emergency, and you don't have to update the connection string. So this is great. And you can also use this for read scale, but note you can only do one failover group. Whereas with geo-replication, you can have multiple replicas, so this can really help you with read scale, and you can even have replicas that are in the same region as the primary. Now, the reason I wanted to show you auto failover groups in this next demo we'll do is because today auto failover groups is available in Azure SQL Managed Instance and Azure SQL Database, whereas geo-replication is only available today in Azure SQL Database. So with that, let's take a look. So now what we're seeing is the virtual machine where I have my demos environment configured. Now, you're seeing a lot of things on this screen. Please don't get overwhelmed. I'm going to explain them in just a moment. Now, let's first look at the left-hand side of the screen. This is Azure Data Studio, which is not a replacement for SSMS, but there are some great things in Azure Data Studio that you cannot get in SSMS. And so what I have here is I'm leveraging the notebook capability that are in Azure Data Studio. And the great thing about notebooks is it allows me to integrate code cells, which I can save the results, as well as text cells. So what you can see here is I'm running in a PowerShell kernel, which means all my code cells are running PowerShell, but there are options for other things here, and you can even enable languages that I don't even have set up on this Azure Data Studio. But what we're going to do is we're going to leverage this, and I'm going to share this notebook in the resources, but basically what I do in this notebook is set up an auto failover group. So we're going to skip ahead, but what you should note is that getting to where we are, So basically getting to a state where we have an auto failover group running only took 6 steps. So it only took me 6 commands to get this thing up and running. And I was able to do it in a matter of, minutes. Maybe within 30 minutes, I had this all set up. Now, the other thing that I'm going to show you on the right-hand side, and this just takes a moment to warm up, but what we're doing here is looking at a Java application. And this Java application basically calls the primary in our failover group. So if you remember, a failover group will have a primary and then it will have a secondary. So what it's going to do is it's going to insert a row on the primary of the failover group, and then it's going to try to read that same row from the secondary. So what you can see here is that we're able to read from the insert on the primary and read from the secondary. Now what I'm going to do is I'm going to run this command, and basically what it's going to do is use this get Azure SQL Database failover group. And it's getting specifically the replication role of what I call the DR server, which in this case is our secondary server. So just remember that this is the DR server. It's currently in the secondary role. Now what I can do is I can actually force a failover as opposed to using this auto failover, but force a failover by using this switch command. And I'm basically going to switch and say, okay, make the DR server the primary server. Now, the awesome thing about this is, like I said with auto failover groups, I don't have to change the connection string. So in the back end, yes, we're going to briefly fail as we try to do a few inserts and reads, but what Azure's doing in the back end is switching the connection strings for us so that we can continue to just connect to the failover group primary or the failover group secondary and get redirected to either the DR server or the regular server. So we can see after 4 or 5 fails, we were able to successfully connect again. And I can again run this command that we ran earlier on the DR server to get the replication role and see that it's now running as the primary. And then if for whatever reason I want to fail back, I can use that same switch command, except I now promote the primary server, not the DR server, to be the primary. Now, one thing I will call out is that as you move to the cloud, this means that having things like retry logic in your applications is going to be really, really important so that when something like this happens, if you have to do some sort of failover, you're not going to become down. And this will be the case in another demo that I show a little bit later on. So we see here right now we're trying to do an insert on the primary and it's failing, and so is the secondary. So again, this is just happening as we fail back over. And that will just take a few moments to see we're able to successfully insert and read again. So hopefully that was an interesting demo, and like I said, I'm going to share the resources for this, and I encourage you to try this on your own to see just how easy it is to set up and just how much power PAS has. That was a bad joke, I'm sorry. Next, so we talked about Azure SQL Managed Instance. We're going to talk next about Azure SQL Database. And this is kind of our flagship offering. This is the first thing we went to the cloud with, so you'll see a lot of the newest innovations will land here first. Now, there are lots of reasons because of the various options available in Azure SQL Database that might lead a customer or an organization towards moving towards Azure SQL Database. One is if you want to build multi-tenanted type of application. Azure SQL Database is going to be great with that. Also, if you want to be able to independently scale compute and storage, or you have intermittent or unpredictable workloads, or you want to have an application with the highest uptime possible with the industry highest SLA, this is going to be, your bread and butter. And also, Azure SQL Database has lots of connectors into other Azure services, so you can really harness the power of Azure. You see a few things on the screen here just to call out a few. Private link support is something we went generally available with in March. This is huge because now it means your whole DNS hierarchy can be completely private in Azure SQL Database, whereas before there was really just a public endpoint. with the help of availability zone isolation, which basically means you can be deployed across multiple data centers within a region. So that protects you against failover even one more level. We're going to be able to get the highest SLA in Azure SQL Database of all our SQL offerings in Azure, as well as the industry highest offerings available, in our competitors. Now, a customer I really like to talk about when it comes to Azure SQL Database is AccuWeather. And I like AccuWeather because really they just wanted to get up and running in the cloud. So they picked Azure SQL Database so that they can immediately start building intelligent applications. So in this case, they were leveraging Azure Machine Learning Services, which is another service in Azure, as well as tools like Azure Data Factory to basically start building intelligent applications. So this is a really great example of using Azure SQL Database. Now, like I mentioned, when we move to Azure SQL Database, what you're doing is you've abstracted away the OS and the SQL Server. And while I mentioned this means, you don't have control over the OS, you don't have access to it, you don't have control over the SQL Server instance in many cases, but we have access to extra telemetry on the Azure side. And what this extra telemetry allows us to do is leverage things like machine learning on the fly in the back end to help make your databases run more intelligently. And one example of this is the automatic indexing capability, part of automatic tuning, which is today only available in Azure SQL Database. So back in my virtual machine, I'm in the Azure portal for Azure SQL Database that I have. Hopefully you've seen this before, but you can see, again, just right off the bat, there's a lot of Azure integration with other services here. But if I go down to performance, the performance overview, I'm going to get a dashboard. And this dashboard has a lot of things on it. First, I can see my top 5 queries by CPU consumption. And I can actually drill into this query, for example, and get the exact query text. And it's going to help me really kind of understand what's taking the most CPU and if I need to scale up or if there are specific queries I should tune. Additionally, I can see my recommendations, my activity for tuning, and the settings that I have for automatic tuning, which we're going to see today. Now, what I'm going to do is I'm going to go into performance recommendations. And what I'm going to see here is a few different actions. Some create indexes, parameterized queries, and drop indexes. I'm also seeing the impact of these potential indexes or changes that I would make, as well as the table and the columns or, the reason for, in that case, parameterized queries. Now, what I can do, notice that there are 2 create indexes. Let's say I want to take a look at this one. If I take a look, I can see exactly what we're thinking is required, the disk space needed, and the potential impact of the recommendation. Additionally, I can go into view script, and what this is going to give me is the exact code that I could select all and apply in my database myself if I want to create this, in this case, non-clustered index. Now, another option that I have is if I go back, I can actually just select apply. And so it says Database Advisor will start the process to create the recommended index and validate it after creation. So we'll talk about a little bit what that means, but what I also have the option to do is automatically apply this in the future. So I'm going to check this and say, hey, I'm managing a lot of databases. If you see an index you think is going to make me run faster, please just apply it. So I'm going to hit OK. And what that's going to do, I think I kicked that off. Maybe I didn't. I'm going to hit OK, and what that's going to do is it's going to immediately kick off both create indexes, and this is because I set it up to automatically do that in the future. Now, the other thing you're going to notice is that these are both in a status of pending. So what Azure SQL Database is going to do is it's going to wait until a period of low resource utilization, then it's going to apply the create index, and then it's going to monitor and validate that it actually did increase the performance. And if it didn't increase the performance, it's going to undo and kind of roll back the actions that it's taken. So this is some really powerful stuff, again, only available today in Azure SQL Database, and just a way to make your databases smarter and faster, especially in a world where you've got a lot of things going on. So that's automatic tuning in Azure SQL Database. Now, the last thing I wanted to mention, because we didn't specifically talk about it, is the pool options that are available in Azure SQL. Now, the first one is Azure SQL Managed Instance. And you might be wondering, okay, why did we do this? Well, Azure SQL Managed Instance today, if you deploy a single instance, it can take a long time because we're essentially deploying a whole virtual cluster and a whole ring for you. What you can do with instance pools, you can pre-provision the pool, and this is going to allow you to then deploy managed instances into that pool much more quickly, and it's also going to allow you to pack them much more compactly, and you can host smaller instances than you can in single instance. The other pooling option we have is in Azure SQL Database, and this is Elastic Pool. And this is going to allow you to resource share between multiple databases, and this is going to allow you to price and performance optimize, and it's going to give you, a single pane of glass to manage if you have, say, a multi-tenant application with many, many databases sharing resources. So those are all the deployment options. Now, once you pick a deployment option, the next decision you have is the purchasing model. Now, if you go to Azure SQL Managed Instance, the option here is simple because you only have the vCore model available. This is a newer model that we have come up with that basically allows you to independently scale compute and storage. This is also Microsoft's recommended model because it allows you to use things like Azure Hybrid Benefit, so gaining cost savings if you have existing licenses, and it allows you to do things like reserve capacity, where this basically means you can say, hey, I'm going to use this much of the service for the next 1 or 3 years, I believe, and you can do that with a significant discount. The DTU model was the model we first went live with for Azure SQL Database, and it basically was supposed to be simple. So basically, you go to one level of DTU and you get a certain amount of compute and storage, but they kind of scale linearly as opposed to independently. For the purposes of this talk, I'm going to focus on on the vCore service model. And within the vCore service model, purchasing model, there are 3 service tiers. The first one is general purpose. And now if you recall, I said with general purpose, you get a failover cluster instance like thing just by deploying. So what this means is basically you have a gateway running in the control ring, and your application is basically going to go to the gateway first, and depending how you have this configured, it will either always go to the gateway or it will get the information for the database and then go to the database. But in general purpose, on your primary replica, you're going to have TempDB running on SSD. However, your data and log files are going to be stored in Azure Premium Storage. This is locally redundant storage. And your backup files are going to be stored in Azure Standard Storage, which is globally redundant storage. So that means right off the bat, your backups are globally distributed, which is going to protect you in times of a catastrophic failure where maybe this whole region goes down. But now, because you have backups in other regions, you can actually do a geo restore, and you didn't have to set up anything. You just get that. Now, if a failover does need to occur, and this will be determined based on Service Fabric and as well as Azure SQL Database, and you can actually force a failover yourself. Basically, it behaves like a cluster instance. So we're going to look for a node with spare capacity. We're going to fail you over, and this connectivity is built in. So again, having retry logic is really important because we're going to fail you over. You might have, a few seconds of downtime, but then you'll be back up and running. Now, if we talk about the business critical service tier, this is structured more like an always on availability group. So at the beginning, you see it looks like general purpose, except on your primary replica, you have TempDB data and log files all running on local SSD. And behind the scenes, we're going to deploy an always-on availability group for you. So at any given time, you're going to have 3 secondary replicas, and one of those secondary replicas we're going to allow you to read from. Now, similar to general purpose, your backup files are stored in Azure Standard Storage, which is globally redundant storage. Now, when a failover needs to occur, for the same type of reasons, potentially, this is really fast. And the reason this is really fast is because you already have a secondary that's almost up to sync or up to sync, just depends. So basically when a failover has to occur, we basically just redirect you to the secondary and then you're up and running. And in the background, we're going to go ahead and deploy you another secondary replica. And again, you can read from one of these secondary replicas. So I just wanted to show you, again, it kind of goes on along with my theme of the power of PaaS. I wanted to show you how fast failovers can occur in both general purpose and business critical without you having to configure anything, and then just how much faster business critical failovers can be. So if you bear with me, again, I'm going to pull up 1000 windows and then I'm going to explain what the heck I just did. So just give me one moment as I set up all these notebooks. Awesome. Okay. So that's not quite what we wanted. Move that there. See if it'll stay there. Okay, cool. So let's take a look at what we have. So what I want you to consider is that the left side of your screen represents a general purpose database. So again, I'm leveraging Azure Data Studio. I have a notebook here connected to my general purpose database in PowerShell. And then down in the left, I just have a PowerShell window. And what I'm going to do is kick off this tool. I'm using a tool called OStress. This is a tool that Bob Ward showed me, and now I use it all the time for simulating workloads or just trying to repeatedly hit a database. So what this query basically does, let me kick it off. What this query basically does is just queries the count in that table and puts the output for general purpose, and does this 50,000 times. So this just simulates, we're querying the database. And we do the same thing over here, except over here on the right, I'm running on a business critical database. Okay, so it's the same thing, except we're just connecting to the business critical database and the business critical tier. Now what I'm going to do is I'm going to initiate a failover on the business critical database and the general purpose database at the same time, and we're going to observe what the effects are. So almost immediately what we see is that the business critical database becomes unavailable. Now so does the general purpose database, but what's happening is in the business critical database, we're switching that connection over to the secondary replica. So you can see it's done before I can even explain what is happening. And with the general purpose, again, so it's like a failover cluster instance. So we're looking for a node with spare capacity, and we can see now we're back up and running. But with business critical, this takes a matter of 2 to 6 seconds, whereas with general purpose, it can take around 30 seconds. Either way, it's pretty powerful, but depending on what your scenario requires, you might be, okay with the failover time that you get in general purpose, or you might need, a faster recovery time that you get in business critical. So again, just to reiterate, business critical and general purpose are service tiers available in both Azure SQL Managed Instance and Azure SQL Database, and they have this very similar underlying architectures which we've seen today. Now, the last service tier, which is today only available in Azure SQL Database, is something we're actively working on in Azure SQL Managed Instance, but today it's only in Azure SQL Database, is hyperscale. And this is really interesting because we basically re-architected SQL Server for the cloud. So we basically broke it up and we use a very clever method of caching layers. And it's similar to what you were seeing before, as you do have like a primary compute. So this is where you're going to connect with your read-write workloads. And you can get 0 to 4 secondary replicas. And now if you pick 0, your recovery time is going to be longer. It'll be more like a failover cluster instance because, again, we're going to have to look for spare capacity and spin that up. But if you have, 1 to 2 to 3 to 4 replicas, your recovery can be more similar to what you get in business critical. I won't go into the super deep details related to this architecture, but one cool thing is that we pulled out the log service completely. So basically, transactions can commit whenever the log service hardens in the landing zone. So you don't have to wait for it to get to one of the secondaries or to the page servers. We're also leveraging snapshot backups which can really help us because they're really fast. So if we take a step back and we consider all the service tiers we've seen today that are available in Azure SQL Database and Azure SQL Managed Instance, I kind of use this to show you how you can compare. So general purpose is where most of our customers are today. So I would recommend, unless you need, low latency, fast recovery, readable secondary, or you need unlimited storage, which you're going to get with hyperscale, which, by the way, isn't the reason I didn't even mention that, but hyperscale allows you to scale up to 100 terabytes in database size, and it also allows you to address size of data operations. And for example, we're able to scale up or down in constant time, regardless of how much data you have. But unless you have one of these situations that really fits in business critical or really fits in hyperscale, general purpose is going to be the way to go. From the number of money signs, I tried to, do this like you would in a rating app for like a restaurant. Business critical is going to be your most expensive option because you're going to get that fast recovery and that always on availability group behind the scenes. Hyperscale is going to fall in between general purpose and business critical for the most part. And it uses a combination of local and remote storage, where in business critical, you're all local, and in general purpose, you're mostly all remote. And the only thing we haven't talked about yet is serverless. Now, serverless is only available in Azure SQL Database within the general purpose tier. In general purpose, you can basically choose between provisioned or serverless compute. Provisioned is what's been the default for the past years. And this basically means that you say, hey, I'm going to use 3 vCores, and regardless of whether or not I actually use them, I'm going to pay for 3 vCores, for example. With serverless, we really built it to address intermittent, unpredictable workloads. So I wanted to dive just slightly into that because it's also a really interesting technology behind the scenes. So if we consider a specific application, let's take a line of business expense reporting application. So this is something that users typically use pretty heavily throughout the course of, the day but especially at the end of the month. Now, after working hours, they don't really use it at all, right? Like most people aren't doing expenses at home for this example. So we could say, this app really doesn't get used at night, and at the end of the month, it really gets these peaks where it needs a lot more performance. So with serverless, what this enables is it enables this application to basically set a min and a max number of vCores and say, okay, on a per second basis, while I'm using this, scale me to the exact max of CPU or memory that I need. And now at the end of the day, so you see here, if I set an inactivity period of, I think here it's like 2 hours, if no one hits the database for 2 hours, then just pause it, automatically pause it. And during this pause time, what we actually do is we shut down SQL Server and we separate the compute from the storage. And during this pause time, you're only paying for storage. So it drastically can reduce your costs if this is a scenario that applies to you. Now, the next morning when, someone logs in and tries to do an expense report, the first time it'll fail, and they will start with a cold cache because SQL Server was shut down. But if they can take that, slight performance hit at the beginning, then they'll ramp up and again be charged on a per second basis based on what they actually use between their limits. Now, this is really interesting technology. We've implemented a really interesting way of reclaiming cache so that we can actually scale you back down. And this auto-scaling type of capability is only available in Azure SQL Database serverless. So we've talked about a lot. We put this slide together, and there's a lot on this slide, but it really hopefully, as you look at it and you kind of digest the different things on this page, you say, oh yeah, I get it. For example, we talked about Azure SQL Database, single database with business critical. You can get the highest availability, that 99.995% of uptime. We also talked about things like SQL Server and Azure Virtual Machine and how you can get, control over the OS, the exact version of SQL Server and OS that you need, as well as some other capabilities. And as well as some other things that are up here. So we hope, at least I hope that you're walking away from today, or I guess you're probably at home. So you're walking away from your desk or your computer or your couch today thinking, okay, I have a bit better handle on what the options are. And not only that, but I really hope that you walk away from today thinking, okay, there are a lot of options, but these options are not here to make me confused. These options are here to help me get exactly what I need. And you can see we've innovated over the years to try to do just that. Now, one thing I'll have you take away, hopefully, is that you can go ahead and see some of the ways we are trying to unify the experience between Azure SQL Database and the other Azure SQL family items. So if I go into my Azure portal, I'm just at the home. It used to be I could select SQL databases, and you can still do that, but today I can select Azure SQL. And this is going to allow me to, if I just filter to one, you'll see a better view. This is going to allow me to see a single pane of glass of all my different SQL services. So SQL databases, SQL Server, SQL Managed Instance, SQL Virtual Machine. I can look at it all in one place and manage them from all in one place. Additionally, when I go to create a new resource, I'm going to get a similar unified type of experience, and this should look similar to that Azure SQL family which I showed you. And if I want to learn more, I can click in and kind of dive a little bit deeper into each of the options. Now, the best thing to me about this whole thing is that it used to be very hard to find the exact image of SQL Server version and OS that you need. But what we've done here is we've really organized that. So you can even search here. And so if we just take SQL Server 2019, I can select it on Windows Server. Depending on my licensing version, this is actually the only cloud where you can actually get SQL Server 2019 Developer on a virtual machine. We also have options for bringing your own license, RHEL, Ubuntu, SUSE, SLES. It's all here, all the way back to SQL Server 2008 R2 on Windows Server 2008 R2. So hopefully this is something that, makes it a little bit easier as you start to think about this option. So in summary, Satya says that Azure is the world's computer. And we like to believe on the SQL team that Azure SQL has evolved into the world's database. We talked about some of the different deployment options. We talked about some of the exciting innovations that we're working on with things like hyperscale and serverless. And so I hope this was useful for you. I showed you one way of how you can choose leveraging the portal. We actually created a new little quiz that can basically, from a few simple questions, recommend a service that's best for your workload. Lots of resources to check out. The two that I'll call out is one is aka.ms SQL Workshops, where myself, Bob Ward, Buck Woody, we've been working a lot on creating this Azure SQL Workshop. It has all the demos that you saw today, as well as many more demos, how to set them up on your own environment. And the next thing is Data Exposed. This is, if you like videos like this and you like hearing from the product group, every week we release videos related to various features at all levels, really meant for all audiences. So thank you for your time. I know there's a lot of things you could be doing at home or wherever it is that you are, but I appreciate your time, and please let us know if there's any feedback that you have, and please find a way to get in touch with me. I think my contact information is at the end if there's anything that I can help you with. Thank you.
Thank you, Anna. So this does conclude the audio portion of our webinar. If you haven't already, please submit your questions into the Q&A window. Please also note that the questions and answers are available every time you access your webinar console. Lastly, we would like to thank you for joining us today, and we hope to see you in an upcoming webinar soon. Have a great day.